Oh, bay, musta? Nanawag lagi ka.
Uy, bay, di ba di makaganahan mat? Na ako'y send ni mo, bago na ako na-discover. Away, send ako ni mo tanawa.
Awa, binakugon sa. Sige, send lang nako, tanawon ko na.
Hello there, fellas. Let's talk about nature. Are you a fan of tigers? Do you like flowers? How about clouds and ocean waves? Then let me tell you something mesmerizing. Do you know that all these can be associated with sequences of patterns? Yep, you heard it right. Now, listen carefully and let us show to you that math exists in nature. Mathematics is the study of patterns and relationships. An art, a language, a tool. It is a way of thinking. Now, glancing around us is a nature that brims with exquisite arts and lovely patterns. Patterns that can be sometimes modeled mathematically. The Fibonacci sequence is found all throughout nature, a naturally occurring pattern. The sequence begins 0 and 1, and then each subsequent number is found after adding the two previous numbers. The numbers in a sequence also form a unique shape known as the Fibonacci spiral, which is again we see in nature, in a form of shells. A few examples of it are spirals in hurricane, pineapples, seed in a sunflower, or a number of petals in a flower.
Symmetries. Symmetry comes from a Greek word meaning to measure together, and it is variously defined as proportion, perfect, or harmonious, and a structure that allows an object to be divided into parts of an equal shape and size. The two main types of symmetry are reflective and rotational. Reflective symmetry means that one half of an image is the mirror image of the other half. Think of it as a butterfly's wings. The size and shape of the left wing is equally proportional to the right side of the wing. Rotational symmetry means that the object or image can be turned around a center point and match itself some number of times. Threefold symmetry or a starfish.
Next is wave pattern. Wave is most often seen when looking at the ocean from above. However, you can also see wave pattern in nature when the wind blows through the crust. From a design perspective, this pattern helps to increase age, which in turn increases your overall productivity.
The last one is stripes. Stripes are made of bud often of the same weight and color along the length. Although not as a mathematically created asymmetrical, it have immediately apparent use in nature. The first and the most recent for stripe in terms of security, like for an example, zebra in flock. Stop lion for being able to track a single zebra, making an attack difficult, while tiger stripes are also a form of camouflage, allowing them to hide throughout the jungle and hunt their prey. In this situation, not only can we look for nature to see solution and opportunity for growth and improvement, therefore, but we can also look to nature to see the problem and how to overcome them.
It's amazing to think how fascinating nature is. The connection between mathematics and nature and how deeply it defines that everything in this universe is connected to each one another, and that in everything, math is involved within. Remember, wherever there is number, there is beauty and nature craves its glamour. I hope you enjoy watching this amazing connection of math and nature into existence.